Hi, welcome to your first math video this year. I'm going to start out with example 1. You're going to be given that the universal set is the set of all elements A, B, C, D, E, F, and G. And you're going to be given that A is the set of elements A, C, E. We want to determine and illustrate the relationship. You're fine. I want you to determine a complement and make a Venn diagram. So in class today, the last thing we saw was that a complement is the set of all the elements in the universal set that are not in A. So a complement is a nice set to make. You could just say that if A is in there, we'll take A off, take C off, and take E off. So a complement is all of the things left in the universal set after we have marked out the things that are in A. So a complement is B, D, F, and G. So now they would like us to make a Venn diagram. So it's just a rectangle. And the whole thing is the universal set. And we have one subset in it. And it's A. Don't I have all the fun toys? And in A, we've just got these elements A, C, and E floating around. And then in the universal set are all the other elements B, D, F, and G. They're just floating around. Nothing special about location or where things are. Well, I mean, it doesn't matter where they are in the circle or where they are in the rectangle, but it does matter that they're in the circle. A, C, and E. Hopefully you understand what I mean there. Okay. Next is the definition for intersection. So the intersection for sets A and B, symbolized by A intersect B. So see that symbol is kind of like a lowercase n, and think intersect. Is the set containing all the elements that are common to both A and B. And that goes with one of the cases that we had today where we had the two circles. Oh, well, I wish I'd started a little higher, but I guess it's okay. The two circles that are intersecting each other. So the intersection is just this region in here. All right, let's try an example. Okay, here's example 3. I have several different sets that have been defined. We have the universal set, set A, set B, and set C. And we're going to use these to answer some questions. The first is A intersect B. So we can draw a Venn diagram for this, or we can look at it and choose the ones that it has in common. They have in common. So intersect is the things they have in common. So as we're looking at A and B, we see they both have 1s, they both have 3s, and they both have 8s. So A intersect B is the set 1, 3, 8. B part is A intersect C. So A and C, it doesn't look on first glance like they have any elements in common. But since C is the empty set, and you think about A, all sets have the empty set. So the set that they have in common is the empty set. C, try to put it down here. A complement intersect B? Well, I don't want to try to keep up with too many things in my head, so I'm going to go ahead and write out what A complement is just up here. So it's all the elements in the universal set that are not in A. So I got to mark 1 out because it's an A. 2 is an A, 3 is an A, and 8 is an A. So all the elements that aren't in A are the other elements that I didn't mark out in the universal set. They are the complement. Now, don't get distracted and think we were done. We want now the intersection of A complement and B. So what do they have in common? Well, A complement has 4, but B does not. A complement has 5, B does not. A complement has 6, and so does B. So there's our first element. A complement has 7, and so does B. 9, nope. 10, nope. So those are the intersection for those two. And D part is parenthesis A intersect B complement. So for this one, you're going to figure out what A intersect B is, and we worked it in A part. There's A intersect B, and we want the complement. So we want all the other elements that aren't these of the universal set. So can't do 1, but I can do 2. Not 3, but 4, 5, 6, 7, not 8, but 9 and 10. Next definition is union, and I forgot I told you I wouldn't do examples, so for the rest of the video I won't be doing as many examples. The union of set A and B, symbolized by A union B, remember that because it looks like a U, is the set containing all the elements that are members of set A or members of set B or both. So if we have a Venn diagram, here's our universal set. Here's set A. Here's set B. So the union is all the members of set A, all the members of set B, and don't worry about that overlapping. It's okay. It said or both. So all of that is the union. For a general rule of thumb, when we say and in a word problem or in a situation in here, that is going to mean the intersection. It's got to be in A and in B. And when we say or, we're going to mean the union. So it can be in A or B or both. And this and is both. The number, a frog? That's cool.